Hello and welcome back to the Studemia channel. Today, we're diving into the world of Linux environment variables. We'll explore what they are, why they're important in Linux, and how you can view and modify them. Let's break this down into simple terms and practical steps. What are environmental variables anyway? Let me explain it simple way. Imagine environmental variables in Linux, like the settings or preferences on your smartphone. These settings control how certain aspects of your phone's system and applications behave. For instance, your phone's language setting determines the language displayed across all your apps. Similarly, environment variables in Linux set preferences for how your system and its applications run. Think of environmental variables as a collection of shortcuts and presets. They hold information like where to find certain files, how to configure the terminal's appearance, or even define the system's time zone. For example, the path environment variable tells the system where to look for executable files. When you type a command in the terminal, path determines where to find that command. Another example is the home variable, which points to your personal user directory. It's like setting a home address for your system, so it knows where your personal files and settings are located. Environmental variables can also influence the behavior of scripts and programs. For instance, setting an environmental variable to enable debug mode in an application can help developers troubleshoot issues. Next, we will take example of system-wide environmental variable and user-based environmental. Now let me explain why it's crucial in Linux. Environmental variables in Linux are crucial because they define the behavior of the system for your user session. They can include paths to essential executable files, user preferences, system locales, and more. Moreover, environmental variables are crucial because they specify paths to essential executable files. For example, the path environment variable contains a list of directories that the system searches to find command line tools and programs. Without the path variable, the system wouldn't know where to look for these executables, and many commands would fail to run. We are going to explore how to display system-wide environmental variables in Linux. We'll specifically focus on the path environmental variable and see how it's used to locate commands like nslookup. Let's begin with a practical demonstration. First, let's see now how we can see system-level environmental path variable. I'm going to type echo then $, then path in the terminal. As you can see, the output is a list of directories. These are the places where Linux looks for executable files. Now, let's say we want to use the command nslookup to query the domain name studemia.com. When we type nslookup studemia.com, and as you can see, domain name resolve and provide us the output. But how Linux finds this command? Linux first looks at the path variable to determine where to search for the nslookup executable. It starts searching in the first directory listed in path. If nslookup isn't found there, it moves to the next directory and so on. Once Linux locates an executable named nslookup in one of these directories, it stops searching and executes the program. If nslookup is not found in any of the directories listed in path, Linux will return an error, typically nslookup, command not found. To find out exactly where nslookup is located, we can use the which command. Let me type which nslookup, and there you have it. The output shows /user/bin/nslookup. This tells us that the nslookup executable is located in the /user/bin directory, which is one of the paths listed in our path environment variable. And that's how you can display and understand the role of system-wide environmental variables like path in Linux. By using echo then $, and then type path and which, we can not only see where our system looks for executables, but also pinpoint the exact location of specific commands like nslookup. This knowledge is crucial for troubleshooting and understanding the inner workings of Linux. Thanks for joining this tutorial and stay tuned for more Linux insights.